Tonight, while you rest, something is holding the entire galaxy off of you. Not the air, not the sky, not even the Earth beneath you, but something much larger and much farther away. An invisible wall at the edge of the solar system that you have never seen and never felt, even though it has sheltered every day of your life. We only learned it was there because we sent 2 machines to fly out through it, and when they crossed to the other side, they sent back a reading that no one expected and no one has fully explained. The same reading, both of them, years apart. The thing that surrounds us, it turns out, does not behave the way it should. So what exactly is pressed against the outside of everything we call home, and why is it still wearing the fingerprint of our own sun? Make yourself comfortable. If you're new here, subscribe if you haven't already, and drift along with these slow trips into the dark. Stick around, because what those 2 machines felt at the wall is not the emptiness you would expect, but something gathering, something heavier, something close. Let's begin. Part 1. 2 voices, 50 years out. Right now, as you settle in and let the day go quiet, there are 2 machines moving through the dark farther from home than anything human hands have ever touched. They are not large. Each one would fit, more or less, inside the footprint of a small car, a body of aluminum and gold and wire with a single wide dish turned permanently back toward a pale point of light it can no longer actually see. They were built by people, many of whom are no longer alive in the years before almost anyone listening to this had been born, and for nearly half a century they have been falling outward, away from the sun, away from the planets, away from everything warm, carrying a few simple instruments and a recorded greeting from a world they will never return to. That greeting deserves a mention, because it tells you something about the spirit in which these machines were sent. Bolted to the side of each Voyager is a golden phonograph record, a gold-plated disc carrying sounds and images of the Earth, the calls of whales, the greetings of people in dozens of languages, music chosen to represent the whole of human culture, a map showing where in the galaxy we are. It was placed there on the slim chance that, in some unimaginably distant future, after the spacecraft have wandered the galaxy for millions or billions of years, some other mind might find one and know that we existed. The records are not really expected to be found. They are more honestly a message from humanity to itself, a way of saying that when we finally reached the edge of our own domain, we wanted to do it carrying the best of who we are. The 2 machines we're following tonight are not cold instruments only. They are also the farthest flung keepsakes our species has ever made, 2 small golden time capsules falling forever outward, and the strange wall they crossed is the threshold past which those keepsakes left home for good. We call them Voyager 1 and Voyager 2. You have heard the names. They are the kind of names that have slipped into the background of the culture, the way the word ocean has, or the word Everest, something enormous that we have learned to stop being amazed by, because it has always just been there. But I want you to actually sit with what they are tonight, because the thing I want to tell you about, the one reading that both of these spacecraft sent home, and that the people who run them still cannot fully explain, only makes sense once you remember how alone these 2 machines really are. Here is the first thing to hold on to, of everything our species has ever made, of every probe and rover and telescope and satellite. Only these 2 objects have crossed the outer wall of the sun's territory and kept going. Only 2, not 200, not 20. 2. Everything else we have built still lives inside the sun's bubble, bathed in the sun's wind, inside the boundary these 2 crossed. So when I say that both Voyagers recorded something strange at that boundary, I am not describing one odd measurement among thousands. I am describing the entire body of evidence we possess, gathered first-hand, about what surrounds our star. This sample size of humanity's direct experience of interstellar space is exactly 2, and those 2 do not entirely agree with our theories, and they completely agree with each other. That, as you will see, is the whole problem. They left in the late summer of 1977, launched within 16 days of one another. Voyager 2 actually went first, on August 20th, and Voyager 1 followed on September 5th, on a faster path that let it overtake its twin out near Jupiter. Think about the world they left. There were no personal computers in people's homes. There was no internet. The most advanced piece of consumer technology a family might own was a television that received 3 or 4 channels through an antenna on the roof. The engineers who designed the Voyager's cameras and sensors were working with computing power that, by today's standards, is almost comically small. The total memory available on board each spacecraft is smaller than what it takes to store a single, low-resolution photograph on the phone in your pocket. And yet these primitive eyes, these slow and careful instruments, have given us the only first-hand map we will ever have, for a very long time, of where our solar system ends. I keep coming back to that phrase, where our solar system ends, because it sounds so simple, and it turns out to mean almost nothing until you ask the obvious question: ends where, exactly? You might picture the edge of the solar system as the orbit of the last planet out past Neptune. You might picture it as the place where the sun's gravity finally loses its grip, far beyond the planets, out in the realm of the distant comets. You might picture it as a kind of finish line, a clean dividing line in space with the solar system on one side and the empty galaxy on the other. Hold all of those pictures loosely, because by the time these two spacecraft are done with us tonight, every one of them is going to feel incomplete. The edge, it turns out, is not a line. It is not even really an edge. It is something stranger, something that behaves more like a living skin than a wall, and the strangest thing about it is the one feature that both Voyagers, 6 years and an entire hemisphere apart, came back insisting was true. For now, just hold the image of the two of them. Voyager 1, the faster twin, the one that has gone the farthest, more than 15 billion miles out and still climbing. Voyager 2, trailing behind on the opposite side of the sky, the only one of the pair whose full set of instruments survived long enough to measure the crossing in real time. Both of them whispering home in signals so faint that by the time those signals reach Earth, they carry less power than the light of a distant star, picked up only by enormous dishes built specifically to listen for ghosts. A message from either spacecraft now takes the better part of a full day to arrive, travelling at the speed of light the entire way. You could send a question tonight and not hear an answer until tomorrow. They are that far. It is worth letting that loneliness be real for a moment, rather than rushing past it. There is nothing else out there with them. No other craft, no relay, no way station, no light but the distant stars. Between each Voyager and the nearest of those stars lie distances so large that even travelling as fast as they are, faster than almost anything humans have ever launched, the spacecraft would need tens of thousands of years to reach one, and neither is aimed at a star anyway. They are simply falling outward through the open dark into the space between, where the sun is a bright point behind them, and the next sun is an unreachable point ahead, and all around is the thin, cold, almost empty medium of the galaxy. And into that solitude, faithfully on a schedule, each one still turns its dish toward home and speaks. That is the picture to keep. Two small, lonely, aging voices, impossibly far apart and impossibly far from us, still talking, still reporting, still trusted to tell us the truth about a place no one else can go. And they are dying. We will come back to this gently, near the end, because it matters and because it gives the whole story a kind of weight. But you should know from the start that these are old machines running on a slowly fading source of power, and that one by one their instruments are being switched off to save the last few watts, and that when the final one goes silent sometime in the next several years, we will have no replacement. Nothing is funded. Nothing is flying. The two voices we're about to follow into the dark are, for the foreseeable future, the only voices we will ever have from out there. So tonight we are going to follow them to the wall. We are going to stand with the scientists who waited years for the signal that would tell them a spacecraft had finally crossed out of the sun's domain. We are going to watch that signal arrive, twice, 6 years apart. And we are going to look closely at the one thing both spacecraft recorded that nobody expected and nobody has fully explained, the reading that made veteran researchers stop and check their instruments and ask whether something had gone wrong, before they realized that nothing had gone wrong at all, that the universe was simply doing something they had not predicted. These were eyes built before the home computer, and what they saw at the edge of everything we call home is still, after all these years, an open question. Let us go out and meet it. Part 2. The Wall Nobody Could See. To understand why both spacecraft sent home something impossible, you first have to understand what they were crossing, and to understand that, you have to start much closer to home, with the sun itself. We tend to think of the sun as a ball of light hanging in space, a thing that warms our faces and lights our days and then sets, and that picture is fine for a morning walk, but it is badly incomplete. The sun is not a quiet ball. The sun is leaking. Constantly, in every direction, from its blazing outer atmosphere, The sun blows a steady stream of charged particles out into space, a thin, hot wind of electrons and protons and heavier ions moving at hundreds of miles every second. We call it the solar wind, and it does not gently drift. It races outward, supersonic, faster than any disturbance can travel back through it, sweeping past the planets and carrying a piece of the sun's own magnetic field stretched out along with it. That wind does not blow forever. Out in the space between the stars, the galaxy has its own thin material, its own gas and dust, and its own magnetic field, what scientists call the interstellar medium. And the solar wind, racing outward, eventually runs into that interstellar material and cannot push any farther. Picture a fountain in a pond, water jetting up and out from the centre, pushing the surface of the pond back in a dome around itself, until at some distance the force of the jet and the weight of the surrounding water reach a standoff and the fountain can push no farther. The sun is that fountain. The solar wind is the jet. And the dome it carves out of the surrounding galaxy, the enormous teardrop-shaped bubble of space that the sun keeps clear with its own breath, has a name. We call it the heliosphere. The helio part simply means sun. It is the sun's sphere of influence, the region of space the sun dominates, the territory it has cleared and claimed and filled with its own wind and its own magnetism. You are inside it right now. So is the Earth, so is the Moon, so are all the planets, so is every spacecraft we have ever built except the two we are following tonight. The heliosphere is unimaginably large. Its outer wall sits more than 100 times farther from the sun than the Earth does, so far that light itself, the fastest thing there is, takes most of a day to reach it. Try to give that distance a shape you can hold. Light from the sun reaches your face in about 8 minutes. It reaches Jupiter in roughly 40. It reaches distant Neptune, the farthest major planet, in about 4 hours, and it reaches the wall, the heliopause, only after most of a day of travel at the speed of light. Everything you have ever called the solar system, all the planets and their moons, sits in the innermost sliver of the sun's true domain, and the rest, the long stretch out to the wall, is mostly empty, dark, and almost never pictured. When the Voyagers crossed the boundary, they were not a little past Neptune. They were more than 4 times farther from the sun than Neptune is, out in a region so removed from the planets that the sun there is just a bright star, casting no warmth, throwing shadows no sharper than a candle across a field. That is the scale of the place these two machines were built to reach, and it is the scale you have to keep stretching your mind toward all night, because the wall is not at the edge of the planets. It is far, far beyond them, in a dark the planets never see. Everything you have ever known, every life that has ever been lived, every ocean and mountain and city, has existed entirely inside this single bubble of solar wind, and almost no one ever thinks about it, because you cannot see it. It is not glowing. It is not solid. It is a region defined not by a surface you could touch, but by a balance of pressures, a place where the sun's outward push meets the galaxy's inward push, and the two hold each other in a standoff that stretches across distances the human mind was simply not built to feel. And the bubble is not a simple thing with a single edge. It has layers, like an onion of force, and it is worth knowing them, because the Voyagers crossed each one in turn and each crossing was its own small revelation. The first layer the spacecraft met, years before the true wall, is called the termination shock. This is the place where the supersonic solar wind, racing outward for billions of miles, finally runs into the resistance of the surrounding interstellar material and abruptly slows, dropping from supersonic to subsonic in a single violent transition, heating and compressing as it does. Imagine a fast river suddenly hitting a broad shallow, the water piling up and churning and slowing all at once. Voyager 1 crossed that inner shock in 2004, and Voyager 2 crossed it in 2007, and the two crossings already carried a clue, because the spacecraft hit the shock at noticeably different distances. The sun's bubble, it turned out, is not a perfect sphere. It is squashed and lopsided, pressed in on one side by the weight of the galaxy. Beyond the termination shock lies a thick, churning region called the heliosheath, where the slowed solar wind piles up and grows turbulent and hot, a kind of stormy outer atmosphere of the bubble, many times wider than the distance from the Earth to the Sun. The Voyagers spent years crossing this region, far longer than anyone had predicted, because it was thicker and more turbulent than the model said it should be. Already, before they ever reached the true wall, the spacecraft were quietly telling us that our picture of the boundary was too simple, too thin, too clean. and only at the far side of the heliosheath, after the termination shock and after all those years in the churning sheath, did each spacecraft finally arrive at the outermost skin, the place where the sun's plasma gives way entirely to the galaxies. So when I talk about the wall, understand that it is the last of several layers, the final membrane at the outer edge of a structure with real thickness and real weather, a structure the Voyagers spent the better part of a decade working their way through. The outer skin of that bubble, the place where the standoff actually happens, is the wall I keep mentioning. Its proper name is the heliopause. Pause, as in a stopping, a place where the solar wind finally pauses and goes no farther. On one side of the heliopause you're still inside the sun's domain, still swimming in solar wind, still wrapped in the sun's magnetic field. On the other side you're out, in the material of the galaxy itself, in the wind not of one star but of all the stars that came before, the mingled exhalations of generations of suns that lived and died long before ours was born. The heliopause is, in the most literal sense available to us, the edge of home. Cross it, and you have left the part of space that belongs to our sun and entered the part that belongs to the galaxy. There is no more meaningful boundary in all of the solar system, and for most of human history we did not even know it was there. Now here is the detail that everything tonight turns on, so let me lay it down carefully, because it is the setup for the whole mystery. The sun's magnetic field and the galaxy's magnetic field do not point the same way. They have different sources, different shapes, different orientations in space. Inside the heliosphere, the magnetic field around you is the sun's, carried out on the solar wind, wound into a particular spiral by the sun's rotation, pointing in a direction set by the sun. Outside the heliopause, in interstellar space, the magnetic field is the galaxy's, the field of the local neighbourhood of stars, pointing in its own different direction, set by forces that have nothing to do with our sun at all. Two different fields, two different directions, with the wall between them. And so the prediction was obvious. It was so obvious that scientists planned their whole strategy around it. When a spacecraft finally crossed the heliopause, when it passed out of the sun's magnetic domain and into the galaxies, the magnetic field around it should swing. It should rotate sharply from the sun's direction to the galaxy's direction, like a compass needle suddenly yanked toward a new north. That rotation would be the proof. That rotation would be the unmistakable signature, the moment you could point to and say, there, right there, that is where we left the solar system because that is where the field turned. For years, as the Voyagers climbed toward the boundary, the mission scientists watched their magnetometers and waited for the needle to swing. It was going to be the headline. It was going to be the clean, beautiful confirmation that humanity had reached interstellar space. That is what makes everything that follows so strange. Because when the moment finally came, when Voyager 1 truly crossed the wall, the solar wind died away exactly as expected, and the cosmic rays from the galaxy surged in exactly as expected, and by every measure the spacecraft had unmistakably left the sun's bubble. Every measure but one. The needle did not swing. The magnetic field, the thing that was supposed to give the cleanest signal of all, simply refused to turn, and for a while almost no one was willing to believe it. We tend to imagine the edge of the solar system as a kind of door, something you pass through and leave behind, the threshold between in and out. Hold on to that image of the door, because by the end of tonight the question we will be left with is whether the door was ever really there at all, or whether the sun reaches through it, into the galaxy, farther than its own light has ever travelled. To see why that question is even on the table, we have to go to the first crossing, to the year 2012, and stand with the people who were waiting for a needle to move that never did. Part 3. The Night the Wind Stopped. For 35 years, Voyager 1 climbed. After it swept past Jupiter and then Saturn at the end of the 1970s, the planets were behind it, and there was nothing left ahead but the slow outward fall toward the boundary, year after year after year, while back on Earth, a generation of scientists grew older waiting for it to arrive. There is a particular kind of patience in that work that I think we should honour for a moment. The people who launched these spacecraft as young researchers were retiring, or gone, by the time the most important measurements came in. You devote your life to an experiment whose answer might not arrive until you are an old man or woman, or until you're no longer here at all to read it. That is the time scale of the edge of the solar system. It does not move at the speed of a career. It moves at the speed of patience. There is a name worth knowing here, because the mission ran for so long that one man became almost synonymous with it. For decades, the chief scientist of the Voyager mission was a soft-spoken physicist who guided the spacecraft and their findings across most of his working life, presiding over crossing after crossing with the same steady care, from the planets in the 1970s to the edge of the solar system many years later. Around him worked teams who had likewise given their careers to these two machines, including the group at the University of Iowa, who built and tended the plasma wave instrument that would eventually catch the interstellar medium ringing. These were people who measured their professional lives against the slow, outward fall of a spacecraft, who knew that the headline result of their work might arrive only when they were old, and who showed up year after year to keep the instruments calibrated and the data clean for a moment that might be decades away. It is hard to convey how unusual that is. Most of science runs on faster rhythms, experiments that finish in months or years, results you can expect to see and argue about while you're still in the thick of your career. The Voyager mission asked something else of its people, a patience closer to that of someone planting trees they will never sit beneath. The termination shock crossings in 2004 and 2007 were themselves milestones that the original planners had only half expected to live to see, and the true wall was still years beyond that. So when the solar wind finally stopped in 2012, the people reading the data were, in many cases, the same people who had waited a working lifetime for exactly that silence, and the moment carried all the weight of that waiting. The patience is part of the story. You cannot rush the edge of the solar system. It arrives when it arrives, and you have to still be there, watching when it does. By the early years of the 2010s, the signs were building that Voyager 1 was getting close. The count of charged particles coming from the sun began to drop. The count of high-energy cosmic rays arriving from the wider galaxy began to climb. These were the expected approach signals, the smell of the boundary getting nearer, and the team watched them sharpen month by month. There were strange flutters, brief moments when the solar particles would almost vanish and then come rushing back, as though the spacecraft were brushing against the edge of something and then sliding away from it again, in and out, in and out. The wall, it seemed, was not a clean line you crossed once. It was ragged. It had fingers and folds. Voyager 1 seemed to be threading through them, and then, in the late summer of 2012, the solar wind stopped. Not gradually. The particles streaming from the sun, the ones that had washed over the spacecraft every second of every day for 35 years, dropped away and did not come back. At the same moment, the galactic cosmic rays jumped to a new and higher level and held there. The date the team would eventually settle on for the true crossing was August 25, 2012, though they would not be certain of it for many months. Voyager 1, after 35 years and more than 11 billion miles, had passed through the heliopause. It had left the sun's bubble. For the first time in the history of a life on Earth, something we had made was outside, in the space between the stars. But here is where the story gets human and a little maddening, and where you understand just how hard this work really is. Voyager 1 could not directly feel the thing that would have settled the question fastest, the instrument designed to measure the density of the plasma around it, the very gauge that could read the thickness of the surrounding space and tell you instantly whether you were in thin solar wind or denser interstellar material, had failed decades earlier. It was dead. So when the spacecraft crossed into interstellar space, it could not simply announce the new density of the medium around it. The team had the dropping particles and the rising cosmic rays, strong hints, but not the direct, unarguable proof. They needed the plasma, and the plasma instrument was silent. What happened next is one of my favourite pieces of scientific improvisation in the whole history of space exploration, and it is worth slowing down for. Voyager 1 carried a second instrument, not a plasma detector but a plasma wave detector, an antenna that listens for vibrations in the charged gas around the spacecraft, the way you might listen for the ringing of a bell. Now charged gas, plasma, has a natural pitch. Strike it, disturb it, and it rings at a frequency that depends directly on how dense it is. Thin plasma rings at a low pitch, dense plasma rings at a higher pitch. If you could just get the interstellar medium to ring, you could read its pitch and calculate its density, and you would know, without any doubt, exactly what kind of space the spacecraft was in. But the interstellar medium does not ring on its own. Something has to strike the bell. The sun struck it. This is the part I love. Every so often the sun has a violent eruption, a great outburst that sends a shockwave barreling out through the solar system and beyond. Months after one of these eruptions, long after everyone on Earth had forgotten it, the shockwave would finally reach the patch of interstellar space where Voyager 1 was drifting, and it would slam into the plasma there and make it ring. Scientists started calling these arriving shocks interstellar tsunamis, waves from the sun crashing on a shore more than 11 billion miles away. And in the spring of 2013, Voyager 1's plasma wave antenna caught the sound. A clear, rising tone, a ringing in the dark at a pitch of about 2,500 cycles per second. I want you to imagine this moment, because it is one of the quietest and most extraordinary moments in the history of our species, and almost no one witnessed it. Picture the data arriving at a control room on Earth in the spring of 2013. The numbers are months old by the time anyone reads them, because they describe an event that happened far away and took the better part of a day just to travel home as a signal. On a screen, a frequency, a pitch, and from that pitch, a density, the thickness of the space surrounding the spacecraft. The number comes out to roughly 80 thousandths of a particle in every cubic centimetre, which sounds like almost nothing, and it is almost nothing, but it is 40 times denser than the solar wind Voyager 1 had lived in for its entire life. It is the density of interstellar space. There it was, in a single rising tone. Not a hint, not a suggestion. Proof. We were outside. The spacecraft had crossed the wall in 2012, and now, listening to the galaxy ring like a struck bell, we finally knew it for certain. A machine built before the personal computer had reached interstellar space, and it told us so by making the darkness sing. I have always wondered what that moment felt like in the room, the moment the team first understood what the rising tone meant. There would have been no fanfare out there, no alarm, no sudden lurch, only a frequency on a screen and a slow dawning realization that the number meant the spacecraft was already, and had been for months, on the far side of the wall. The crossing itself had happened the previous summer, silently, unwitnessed, while everyone was looking at other data, and only now, with the plasma singing, could they look back and put a date on it. There is a particular kind of wonder in learning that a threshold you had waited your whole career to see had already been quietly passed, that the great event had occurred in the dark without ceremony and announced itself only later in a tone. The edge of the solar system was crossed and nobody felt it happen. We only heard about it afterward, in a song the galaxy sang when the sun happened to strike the right note. And for a little while, that was the whole story, and it was glorious, and the world celebrated, and the headlines were about a spacecraft reaching the stars. But underneath the celebration, in the magnetic data, there was something the team kept turning over and could not make sense of. The wind had stopped. The cosmic rays had surged. The plasma had sung its high interstellar note. Everything agreed that Voyager 1 was out. Everything except the one measurement that was supposed to be the surest sign of all. The magnetic needle, the field that was supposed to swing as the spacecraft left the sun's domain, had not swung. And the more carefully they looked at it, the stranger it got. Because the field out there, in the galaxy, on the far side of the wall, was still pointing very nearly the way the sun's field had pointed on the inside. That was not supposed to be possible, and it was about to become the most quietly unsettling result the mission ever produced. Part 4. The Needle That Didn't Move. Let me try to put you inside the strangeness of it, because numbers on a screen do not carry the weight of what the team was looking at. Imagine for a moment that you are the magnetic field surrounding Voyager 1. Not the spacecraft, but the field itself, the invisible web of force threading through the space the spacecraft moves through. For 35 years you have pointed a particular way. You are the sun's field, carried out here on the sun's wind, and although you have weakened over those billions of miles, you have kept your direction, the orientation set by the star at the centre of everything. You are, in a sense, the sun's signature written across space, a single long sentence the sun has been speaking outward since before the spacecraft launched. Now the spacecraft carries you to the wall. This is the moment. This is where you are supposed to let go of the sun and take up the galaxy's direction instead, where the sun's long sentence ends and the galaxy's begins. The crossing comes, the wind on the inside dies, the cosmic rays from the outside flood in. By every other measure the spacecraft has left, and you, the field, the needle, the thing that was supposed to turn, the thing whose turning was the entire point, you do not turn. You hold. You keep pointing the way the sun told you to point out here, in the space that is supposed to belong to other stars. You stand still where you were ordered to move, Stay in that strangeness with me for one more breath, because it is the hinge the whole night turns on. You are the field, and you have just done the one thing you were never supposed to do, which is nothing. All around you, the other signs of crossing are unfolding exactly on schedule. The solar wind falling away behind, the galaxy's hard radiation washing in ahead, the thin plasma shifting to its denser interstellar note. The crossing is real. Everyone agrees the spacecraft is out, and you, the surest witness, the one whose testimony was supposed to settle everything, simply hold your direction and say nothing new, as though the order to turn never reached you, as though, out here past the wall, the sun was still quietly insisting that you point its way. There is no drama in it, no violence, no sudden event. There is only an expected motion that does not happen, a stillness where a swing should be, and that absence, that quiet refusal, is the single most important thing either spacecraft ever recorded. The universe did not do something loud at the edge of the solar system. It declined to do something, and the declining is the mystery. That stillness is the mystery. That is the one thing both Voyagers recorded that nobody can fully explain, and we have only just met the first half of it. When the Voyager 1 team first saw it, in the months after the 2012 crossing, the natural reaction was disbelief. Maybe the spacecraft had not really crossed. Maybe this was one of those ragged fingers of the boundary, a place that looked like interstellar space but was really still a fold of the sun's bubble. The non-turning field was even used for a while as an argument that Voyager 1 had not yet truly left, precisely because the field had not done the one thing leaving was supposed to make it do. The reasoning was circular and everyone knew it. If the field rotation is how you define the crossing, and the field never rotates, then how do you ever say you crossed? The plasma instrument in the end broke the deadlock. The high singing note of dense interstellar plasma was not something a fold of solar wind could fake. The density said, without question, you are out. And so the team was forced into the uncomfortable conclusion. We are outside the sun's bubble, and the magnetic field out here is still pointing the sun's way. Both of those things are true at once, and we did not expect the second one, and we are not sure why it is happening. You have to understand how much this unsettled people, because magnetic fields were supposed to be the reliable part. Plasma can be patchy. Particle counts can flutter. But the large-scale direction of a magnetic field is a sturdy, slow, dependable thing, the kind of measurement physicists trust. To find the galaxy's field combed into near alignment with the sun's, at the only place we had ever been able to check, was like sailing across an ocean to a foreign country, and finding that the compass there still pointed toward the home you had left. To feel why this rattled people so badly, you have to understand why physicists trust magnetic direction in the first place. Many measurements in space are jittery and local. The count of particles can flutter from minute to minute. The density of plasma can vary from one pocket to the next. But the large-scale direction of a magnetic field is a slow, sturdy, dependable thing, set by enormous structures and enormous distances, the kind of quantity you can lean on. When you ask which way a magnetic field points across a whole region of space, you're asking a question with a stable, trustworthy answer, the closest thing to bedrock that this kind of science offers. That is exactly why the field rotation had been chosen as the definitive marker of the crossing. It was supposed to be the reliable witness, the one measurement that would not lie. And there was a further wrinkle that made the early days genuinely confusing. In the months before the true crossing, Voyager 1 had encountered strange structures the team came to call magnetic highways or flux tubes, regions where particles from inside the bubble seemed to be leaking outward and particles from the galaxy seemed to be leaking inward, along connected magnetic field lines, as though doorways had opened in the wall ahead of the spacecraft. These were not predicted either, and at first no one was sure what they meant. Were they the crossing itself? A precursor to it? Some entirely new feature of the boundary? For a while the situation was a genuine muddle, with different instruments seeming to tell different stories, and serious scientists publicly disagreeing about whether Voyager 1 had actually left the solar system at all. The non-turning field sat at the centre of that argument, the stubborn fact that would not fit. It took the singing plasma, the high interstellar note, to finally settle the question of whether the spacecraft was out, but settling that only sharpened the deeper puzzle, because now there was no doubt, the spacecraft was outside, and the field still would not turn. It suggested that the boundary was doing something to the field, draping it, bending it, organising it, in a way the simple models had not captured. Or it suggested something stranger, that the sun's reach did not really end at the wall, that the star's influence bled outward across the boundary into the galaxy beyond, so that even out there you were not fully free of it. But, and this is crucial, it was still only one spacecraft. That was the saving grace, the thing that let people sleep. Voyager 1 was a single probe, at a single point, on one particular side of the heliosphere, passing through one particular patch of the boundary at one particular moment in the sun's 11-year cycle of activity. Maybe the non-turning field was a local quirk. Maybe Voyager 1 had simply crossed at an unusual spot, a place where the field happened to be draped just so, and a different crossing somewhere else would show the clean rotation the theory predicted. A single measurement, however strange, is just a story. It is not yet a law. To know whether the still needle was a fluke of one place or a property of the whole boundary, you would need a second crossing, somewhere else entirely, made by a different spacecraft with different instruments, far away in space and years apart in time, and as it happened there was a second spacecraft. Voyager 2 was still inside the bubble, still falling outward, on the opposite side of the heliosphere, approaching its own appointment with the wall. So the scientists did what scientists do when a result is too strange to trust and too solid to ignore. They wrote it down carefully, they argued about it at conferences, they built models to try to explain the draping of the field, and they waited. They waited the way the mission had always made them wait, on the timescale of patience rather than the timescale of careers. Voyager 2 would not reach its crossing for years yet. But it was coming, and the question it carried toward the boundary was sharp and simple and enormous. When Voyager 2 finally broke through to the other side, would its needle turn the way the theory said it should? Or would it too find the galaxy strangely wearing the fingerprint of our sun? Hold that question in your mind as we go forward, because the answer, when it came, is the moment a strange reading stopped being a story and became a fact. Remember the phrase, the needle that didn't move. We're going to need it again very soon, on the far side of the sun's bubble, 6 years later, in the data of a second spacecraft that was not supposed to agree. Part 5. 6 years, the other side, the same impossible reading. Voyager 2 had taken a different road. Where its twin had been flung up and out of the plane of the planets after Saturn, Voyager 2 had stayed lower and slower, lingering to visit Uranus and Neptune in the 1980s, the only spacecraft in history to see those distant worlds up close. That grand detour cost it time and changed its heading, so that it approached the wall on a completely different part of the sky than Voyager 1, on the opposite flank of the heliosphere, like two people leaving the same house through doors on opposite sides and walking off in different directions. This matters enormously for our story. Whatever Voyager 2 found at its crossing would be an independent test, a measurement of a different piece of the boundary, made by a different machine, at a different time in the sun's cycle. If the two spacecraft agreed, you could no longer wave the result away as a local quirk. Agreement across that much distance and time is the closest thing science ever gets to certainty. And Voyager 2 carried one priceless advantage. Its plasma instrument, the very kind that had died on Voyager 1 year before the first crossing, still worked. It was alive. This meant that when Voyager 2 reached the wall, it would not have to wait for the sun to ring the interstellar bell months later. It could feel the plasma directly, in real time, measuring the density and the speed and the temperature of the medium around it as it actually crossed. For the first and so far only time in history, a working plasma instrument would record the crossing of the heliopause from the inside out, moment by moment. Whatever the edge of the solar system actually felt like, Voyager 2 was about to take its pulse, and the pulse it took was full of fine detail that its blind twin could never have gathered. As Voyager 2 approached the wall, its plasma instrument watched the solar wind ahead begin to change character, across a region more than a full Earth-Sun distance wide, the plasma slowing and bunching and warming, growing about twice as dense as the ordinary heliosheath behind it. The temperature out there is a strange thing to describe, because the numbers sound violent, and the reality is gentle. The particles in this boundary region are, by one measure, ferociously hot, moving at speeds that correspond to tens of thousands of degrees. And yet the gas is so unimaginably thin, so close to a perfect vacuum, that a spacecraft sitting in it feels almost no warmth at all, because there are far too few particles to actually carry heat to it. It is the paradox of the outer solar system, a place that is scorching and frozen at the same time, blazing by the speed of its sparse particles and bitterly cold by any measure that would matter to a living body. Then came the inner boundary layer, much thinner, just inside the true wall, where the speed dropped and the density and magnetic field both climbed in a sharp final step. And then the heliopause itself, abrupt and clean. Crucially, Voyager 2 also detected, in the piled-up plasma and intensified field just inside the wall, a feature that came to be called a magnetic barrier, a region of strengthened magnetic field that appears to regulate how the galaxy's cosmic rays leak inward through the boundary. We will return to that barrier later, because it turns out to matter a great deal for what the whole bubble is doing for us. For now, hold the picture of Voyager 2, the only spacecraft in history with a living plasma sense at the crossing, moving step by step through a structured, layered, breathing boundary, feeling the wall not as a single line but as a sequence of changes, and recording every one of them for a species that had never felt any of it before. The crossing came on November 5th, 2018, at a distance of about 119 times the distance from the Earth to the Sun, a little closer in than Voyager 1's crossing had been, which itself was a small surprise, and a hint that the bubble is not a perfect sphere. And the real-time data was a revelation. Voyager 2 did not punch through a single sharp wall. It moved through a structured boundary, a layered region. For a stretch of space more than a full Earth-Sun distance wide, the plasma ahead of the true crossing began to change, slowing down, heating up, growing about twice as dense as the ordinary solar wind behind it. The spacecraft was pushing into a kind of pile-up zone, a region where the solar wind was being compressed and braked as it neared the wall. Then came a much thinner inner layer, and then the crossing itself, sharp and clean, the solar particles dropping away and the galactic cosmic rays surging in, just as they had for Voyager 1 6 years before. Interestingly, Voyager 2's crossing was thinner and simpler than its twins. It did not see the ragged fingers, the in-and-out flutters, the precursor bursts of escaping particles that Voyager 1 had threaded through. The same wall, crossed in two places, had shown two different textures, one ragged and one smooth, which is itself a clue we will return to. But you already know the question that mattered most. You have been holding it. When Voyager 2 crossed out of the Sun's domain, when its working instruments confirmed beyond any argument that it had entered interstellar space, did the magnetic needle turn? It did not. 6 years after Voyager 1, on the opposite side of the heliosphere, through a different patch of the boundary, measured by a different and in this case healthier set of instruments, the magnetic field on the far side of the wall was once again pointing very nearly the way the Sun's field had pointed on the inside. The needle that didn't move had not moved here either. The thing that could have been a fluke of one place had just happened again, in a completely different place, years later, exactly as before. And in that moment the result changed character entirely. It stopped being a strange story about one spacecraft. It became a property of the boundary itself, a fact about the edge of our solar system, confirmed by the only two measurements humanity will possess for a generation. I want to dwell on the weight of that, because it is the emotional centre of this whole journey. There is a particular feeling that scientists describe, rare and a little vertiginous, when a result you had hoped was a mistake comes back and looks you in the eye a second time. As long as Voyager 1 stood alone, you could hope. You could tell yourself the model was basically right, and the spacecraft had just caught the field in an odd spot. The second crossing took that hope away. Two lonely instruments built half a century ago, separated by 6 years, and by a distance so large that light itself needs more than a day to cross between them, agreed on something that no theory had ordered them to find. That is the moment a fluke becomes a fact. Not the first time you see it, when you can still doubt. The second time, when the universe repeats itself far away and dares you to keep pretending you understand. I think most of us go through life having quietly decided that the big questions are settled, that somewhere there are experts who understand how it all fits together, that the edges of knowledge are far away and well guarded. And then occasionally something punctures that, and you realise the experts are standing at the same dark window you are, looking out at something they cannot explain, holding two measurements that agree with each other and with nothing else. The non-turning field is one of those punctures. It is not a gap in a textbook that will be filled in next year. It is the considered, published, repeatedly confirmed finding that the edge of our own solar system behaves in a way our best theories did not predict, recorded by the only two witnesses we have, who happen to agree completely. There is something steadying in that, oddly, even as it unsettles. The universe is not finished surprising us. The frontier is real, and it is not far away in some other galaxy. It is at the edge of our own front yard, in the dark past the planets, where two old machines are still insisting on something we have not yet learned how to understand. The field does not turn at the edge of the solar system. Both Voyagers say so. The cleanest, surest, most trusted signature of leaving the sun behind, the one the whole mission strategy had been built around, simply does not occur. And the natural human response, the response the scientists themselves had, is to ask the next question, the one that is going to carry us into the centre of tonight's mystery. If the galaxy's magnetic field, out there past the wall, is pointing the sun's way, then in some sense the sun is still out there too. Its fingerprint is on the field. Its signature is still being written, past the boundary that was supposed to be its end. What does it mean for the sun to reach through its own wall, into the space that belongs to other stars? That is where we go next, and it is where the comfortable idea of an edge begins, very gently, to come apart in our hands. Part 6. A Galaxy. Wearing the sun's fingerprint. So let us ask it plainly. Why would the galaxy's magnetic field, on the far side of the heliopause, be combed into near alignment with the sun's? Why does the needle refuse to turn? The scientists who study this have a leading idea, and it is worth understanding, both because it is probably at least partly right, and because, even if it is right, it does not make the strangeness go away. It only relocates it. The leading idea is called draping. Picture the heliosphere, the sun's enormous bubble, moving through the galaxy. It is not sitting still. The whole solar system is sweeping through the local neighbourhood of the galaxy at a brisk pace, ploughing through the thin interstellar material like a boat moving through water. Now, the galaxy's magnetic field is threaded through that interstellar material, and as the heliosphere ploughs forward, it pushes against that galactic field, and the field, rather than passing cleanly through, drapes over the outside of the bubble, the way a flag wraps around its pole in the wind, the way water folds smoothly around the bow of a moving ship. Right up against the wall, on the outside, the galaxy's field gets pressed flat against the heliosphere, and bent, dragged out of its natural direction, and pulled into a new orientation that follows the curve of the bubble. And that draped, bent, reorganized field, it turns out, can end up pointing in roughly the same direction as the sun's field just inside the wall. The two need not match by some underlying law. They match because the boundary itself combs them into agreement, pressing the outside field into line with the inside one along the surface where they meet. There is a second piece to it, a process called reconnection, in which the sun's field lines and the galaxy's field lines pressed together at the wall actually link up and splice into one another, stitching the two domains together along the boundary, rather than leaving them as two separate sheets, with a clean seam between them. Between draping and reconnection, you can begin to see how the field might fail to make its sharp predicted turn, how the edge might be less a clean wall between two magnetic countries, and more a blurred and braided borderland where the two fields fold into and through each other. There is a further detail that deepens the puzzle rather than resolving it. The two spacecraft did not even measure the same field strength on the far side. Voyager 1 found the interstellar magnetic field stronger than expected, roughly twice the strength the models had predicted. And Voyager 2, on the opposite flank, found it stronger still. The galaxy's field out there is more muscular than anyone thought, and it is not uniform. It differs from one side of the bubble to the other, which is exactly what you would expect if the field is being draped and compressed unevenly around a lopsided heliosphere. A stronger, draped, uneven field pressed against the wall does more than fail to turn. It grips harder than we imagined, which feeds directly into the shield story we will come to, because a stronger boundary field is a more effective barrier against the cosmic rays trying to get in. The non-turning needle and the surprising field strength are two faces of the same fact. The magnetic environment at the edge of the solar system is more forceful, more structured, and more tangled with the sun's own field than the clean models ever allowed. It is a good idea. It is probably part of the truth, but notice what it does and does not solve. It explains how the field could be combed into alignment without violating any laws of physics, which is genuinely reassuring. What it does not do is restore the comfortable picture of a clean edge, just the opposite. If draping and reconnection are real, then the boundary of the solar system is not a line you cross once and leave behind. It is a thick, braided region where the sun's influence and the galaxies are tangled together, where the sun's field reaches across the wall and grips the galaxies, where, in a real and measurable sense, the sun is still present on the far side of its own boundary. The fingerprint we found on the galaxy's field is not an illusion. It is the genuine reach of our star, extending past the place we had drawn its edge. And here is the part that I find quietly staggering, the place where I want you to slow your breathing and just sit with it. Both Voyagers, at both crossings, found the field still aligned, but neither spacecraft has ever clearly found the place where the field finally lets go of the sun and turns to point the galaxy's true way. As far out as they have gone, more than 150 times the Earth-Sun distance, the needle has not made its turn, which means we do not actually know how far the draping reaches. We do not know how thick the braided borderland is. We do not know where, if anywhere, you would have to go to find magnetic fields that have entirely forgotten our sun. It might be a little farther than the Voyagers have reached. It might be far, far beyond them, a distance neither spacecraft will ever live to measure. The honest answer is that we have never found the true edge of the sun's magnetic reach, because at the only two places we have ever been able to look, the sun was still there. Think about what that does to the idea of leaving home. We send two machines to cross the edge of the solar system, and they cross it. By every measure of wind and cosmic ray and plasma density, they have left the sun's bubble, and yet the sun's own field is still wrapped around them, still pointing them the way it always has, like a hand on the shoulder that you cannot quite shrug off no matter how far you walk. There is something almost tender in it, and something almost claustrophobic in it, depending on the mood you bring to it. I keep landing on the word tender, and I think it is the right one, because there is genuine comfort hidden inside this strangeness, if you let yourself feel it. We are so used to stories of cosmic indifference, of a universe that does not know we are here and would not care if it did, of an Earth that is a lonely speck in an uncaring dark. And here, at the very edge of our domain, the data tells a slightly different story. The sun's reach does not abandon its children at a wall. It extends past the boundary, wraps around it, presses its own direction into the galaxy beyond, so that even the farthest things we have ever sent are still, in a measurable way, held. You can read that as confinement if your mood is dark, the inability to ever fully escape. Or you can read it as accompaniment, the sense that home comes with you farther than you knew, that the star which warmed every day of your life does not simply switch off at some line in the dark, but keeps a hand, however faint, on everything that leaves. The Voyagers went looking for the end of the sun's influence, and what they found instead was how far that influence quietly travels, out past the planets, past the wall, into the space between the stars, still pointing the way home. The star that made us does not simply stop at a wall, it reaches. It drapes itself over the boundary and presses its direction into the galaxy beyond. And the comforting line we drew, the clean edge of home, turns out to be the place where the sun's grip begins to loosen, not the place where it ends. We have been talking about the field, the first half of the mystery, the needle that would not move, but the Voyagers found a second strange thing past the wall, something about the very texture of space out there, and it points in the same unsettling direction. We expected the edge of the solar system to be the beginning of emptiness. Instead, the deeper the spacecraft go, the less empty it becomes. Out past the wall, space does not thin out, it thickens, and that thickening, that slow gathering of pressure against the outside of everything we call home, is where we turn next. Part 7. Space that gets heavier. There is an assumption buried so far down in the way we talk about space that we almost never notice it is there. We say outer space, the emptiness of space, and we picture leaving the solar system as a journey into ever greater nothing, the planets thinning out behind you, the sun shrinking to a star, and ahead only a growing, deepening emptiness all the way to the next sun. Leaving home, in this picture, means entering the void. The farther out you go, the emptier it gets. It is such a natural idea that it feels less like a theory and more like common sense. And the Voyagers, with their primitive instruments and their patient half-century vigil, have quietly shown that at the edge of the solar system, common sense has it backwards. Remember how Voyager 1 finally proved it had crossed the wall. The plasma wave instrument caught the interstellar medium ringing, and from the pitch of that ringing the team read a density, about 80 thousandths of a particle per cubic centimetre, 40 times denser than the solar wind. That number was the proof of crossing. But the team did not stop listening after that one note. The sun kept erupting. The shock waves kept rolling out and slamming into the interstellar plasma and making it ring again and again over the following years, and each time the spacecraft caught the pitch and read off a new density. And when they lined those densities up in order, something unexpected emerged. The density was not holding steady. It was not falling. It was climbing. Just past the wall, the density was around 55 to 80 thousandths of a particle per cubic centimetre. A little farther out it had risen. Farther still, higher again. By the time Voyager 1 had travelled to around 160 times the Earth-Sun distance, the density of the space around it had climbed to about 120 thousandths of a particle per cubic centimetre, roughly double what it had been near the boundary. The deeper the spacecraft pushed into interstellar space, the thicker that space became, and in 2020 the spacecraft ran into a distinct feature, a kind of front, where both the density and the magnetic field strength jumped upward together by about a third in a single step, as though it had pressed into a denser bank of material, a swell in the medium. For a long time, the only way to read the density at all was to wait for the sun to ring the bell, to wait for one of those interstellar tsunamis to roll out and strike the plasma and make it sing, which meant the measurements came in scattered bursts, months or years apart whenever a shock happened to arrive. Between the shocks, silence, and a gap in the data. But then, more recently, the Iowa team noticed something they had nearly overlooked. A faint, steady, persistent tone underneath everything. A continuous low hum in the plasma wave data that was always there, quietly, between the louder rings of the shocks. The interstellar medium, it turned out, is not silent between the tsunamis. It is humming all the time, a faint constant note produced by the ordinary jostling of the thin gas itself. And because that hum, like the louder rings, carries the pitch of the surrounding plasma, it gave the team a way to track the density continuously, not just in scattered bursts, but as a steady ongoing reading, the spacecraft listening to the quiet song of interstellar space and reporting, note by note, how thick the medium around it had become. That faint hum is one of the loneliest and most beautiful measurements I know of. Picture it. More than 100 times the distance from the Earth to the Sun, in a place with no day and no warmth, a spacecraft sits and listens to the almost silence of the space between the stars, and finds that it is not quite silent, that the galaxy itself is faintly singing, a single sustained note so low and so steady that it took decades and a dying spacecraft to notice it. And the slow drift of that note, the way its pitch has climbed over the years, is how we know the density is rising, how we know the wall gets heavier the farther you go. The universe gave us a tone to listen to, and 2 old machines were patient enough to hear it. Space, out past the edge of the solar system, was not emptying out. It was piling up. Let me try to make this something you can feel rather than just a column of numbers, because the meaning of it is genuinely strange. Imagine you could ride along with Voyager 1, drifting outward past the wall, expecting the famous emptiness, the famous void, and instead, with every step you take away from home, you feel the space around you grow very slightly heavier. Not heavy the way water is, nothing you could splash or swim in. The densities here are still a near-perfect vacuum by any earthly standard, millions upon millions of times thinner than the air in the room around you. But relative to itself, relative to where you started, the medium thickens. There is more of it the farther you go. You're not falling into nothing. You're pressing into something, a slowly gathering substance, a swell of charged gas heaped up against the outside of the bubble you came from. The wall gets heavier the farther you go. Hold that phrase, because it is going to come back and mean something else by the end. Why would space pile up at the edge of the solar system? The leading explanation is, in a way, the same physics we met with the magnetic field, just expressed in matter instead of magnetism. The heliosphere is ploughing through the interstellar medium, and the medium does not simply part and slide cleanly past. It bunches up in front of the bubble, compressed and slowed and heaped against the outside of the wall, the way water mounds up at the bow of a moving ship, the way snow gathers in front of a plough. The Voyagers are not sampling the calm, undisturbed galaxy. They are crossing through the heaped-up region right in front of the heliosphere, the pile-up zone where interstellar material is being braked and compressed by its encounter with the Sun's domain. The rising density is the signature of that pile-up. It is a wall of pressure, pressed against the outside of everything we call home, And this is where the two halves of tonight's mystery begin to rhyme, where you can feel them reaching toward each other. The magnetic field would not turn, because the sun's influence drapes across the wall and combs the galaxy's field into line, and the density keeps rising, because the sun's bubble pushes against the galaxy's material and heaps it up against the wall. Both findings say the same uncomfortable thing in two different languages. The boundary of the solar system is not a clean line where the sun ends and the galaxy begins. It is a thick, active, pressurized borderland, a region with depth and structure and weather, where the sun and the galaxy are pressed up against each other and tangled together across a span we have not been able to measure the far side of. The Voyagers have not crossed a line. They have entered a frontier, and they are still inside it, and we do not know how far it goes. There is even a real question, raised seriously by some of the scientists involved, of whether the Voyagers have truly reached undisturbed interstellar space at all, or whether everything they have measured so far is still part of this pile-up, still inside the zone the sun is actively pushing on. This is exactly the question a purpose-built successor would be designed to answer, and scientists have sketched such a mission in real detail. A true interstellar probe built from the start to cross the wall and keep flying, far faster and far farther than the Voyagers ever could, out to several times the distance they have reached, to find the place where the field finally turns and the density finally levels, and the genuine, undisturbed galaxy at last begins. Such a probe would settle in a few decades what the Voyagers can only hint at: the actual thickness of the borderland, the true shape of the bubble, the real edge of the sun's reach. But it would have to be built and launched, and then given the long years of flight, and as we will see near the end of tonight, none of that has begun. For now, the honest situation is this: we have crossed into what we call interstellar space, twice, and we cannot say for certain that we have truly left the sun's influence behind, because at the only two places we have ever measured, the sun is still unmistakably there, in the aligned field and the rising pressure, refusing to fully let go. By the strict definitions, the wind and the cosmic rays say they are out. But if the density is still climbing and the field is still aligned, then in a softer, deeper sense, they may still be inside the sun's reach, still in the borderland, with the truly free galaxy lying somewhere farther out than either spacecraft will ever get. That is a humbling thought. We sent 2 probes to leave the solar system, and the closer we look at their data, the less certain we are that they have entirely managed it. Pressure balance physics, the basic accounting of push against push, predicts that the density should rise sharply across this boundary, by a large factor, possibly 20 to 50 times, as you move from the thin heliosheath just inside the wall to the compressed interstellar material outside it. So the rising density, on its own, is not the shocking part. The physics broadly expects a pile-up. The shocking part, the part that keeps the story open, is the same one we keep returning to. We have only 2 measurements of any of this: 2 spacecraft, 2 crossings, 2 thin threads of data drawn through a structure larger than the human imagination was built to hold. We can see that the edge is heavier and stranger than we thought. We cannot yet see its shape, and before we can even try, the data throws a third clue onto the table, a faint ultraviolet glow that has been puzzling people for decades, and that points, once again, to a boundary that is fuller than it has any right to be. Part 8. The boundary breathes. I told you to hold on to a small detail from the 2 crossings, and now it is time to pick it back up, because it opens onto something I find genuinely beautiful about this whole story. Remember that when Voyager 1 crossed the wall in 2012, it had a messy, ragged time of it. For months beforehand, it kept brushing against the boundary, the solar particles almost vanishing and then rushing back, in and out, as though the spacecraft were threading through fingers and folds of the edge. There were precursor events, bursts of escaping particles leaking out through gaps in the wall before the true crossing. It was complicated, it was structured. The boundary, for Voyager 1, was a tangled and many-layered thing. Now remember Voyager 2, 6 years later, on the opposite side of the heliosphere. Its crossing was thinner, cleaner, sharper. It did not see the same ragged fingers or the same leaking precursor bursts. It moved through a wide pile-up region of slowing, heating plasma, yes, but the heliopause itself, the true wall, was a more abrupt and simple step than the one its twin had stumbled through. Same boundary, 2 crossings, 2 completely different textures, one ragged and one smooth. What does that tell you? It tells you the edge of the solar system is not a fixed frozen shell. If it were a static wall, the same everywhere and always, The two crossings should have looked broadly alike. Instead, they looked different, and they looked different for reasons we can partly understand. The two spacecraft crossed at different places on the bubble, and the bubble is not a perfect sphere, so different parts of its surface naturally have different shapes. But they also crossed at different times, 6 years apart, and in those 6 years the Sun itself had changed. The Sun runs on a roughly 11-year cycle of activity, swinging from quiet to stormy and back again, and as it does, the pressure of the solar wind it blows rises and falls. When the Sun pushes harder, the bubble inflates and the wall moves outward. When the Sun eases off, the bubble relaxes and the wall draws inward. We can actually watch a faint version of this from home, which is part of how we trust it. Even here at the Earth, instruments that count cosmic rays see the numbers rise and fall in step with the Sun's 11-year cycle, climbing when the Sun is quiet and the bubble relaxes, dropping when the Sun is active and the shield strengthens. The breathing of the boundary leaves its fingerprint on the radiation reaching our own planet, a slow tide that rolls in and out across roughly a decade. So when the Voyagers crossed the wall at slightly different distances, they were not catching a static boundary at two arbitrary points. They were catching a living surface at two different moments of its breathing, one nearer an inhale and one nearer an exhale, the wall itself having moved between the two crossings as the Sun changed its mood. The edge of the solar system has a rhythm. It is not the steady rhythm of a clock, but the slower rhythm of a chest, rising and falling on the Sun's long breath, and the two old spacecraft are the only things that have ever touched it while it breathed. The edge of the solar system is not parked at a fixed distance. It breathes. It moves in and out with the mood of the Sun, year by year, like a chest slowly rising and falling. This is why the two crossings happened at slightly different distances, Voyager 1 a little farther out, Voyager 2 a little closer in. It is not only that the bubble is lopsided, though it is that the wall was in a different position at the two moments, because the Sun was in a different part of its cycle, breathing the boundary to a different size, and it means that if you sent a third spacecraft across tomorrow, it might find the wall somewhere else again, in yet another texture, because the thing it was crossing would have shifted in the meantime. We are not studying a monument. We are studying a living surface, one that flexes with the Sun's 11-year pulse and ripples with whatever the local interstellar weather happens to be doing as the solar system sails through it. This single idea, that the edge is alive rather than fixed, quietly rewrites the meaning of every measurement the Voyagers made. A number taken from a fixed wall is a fact you can carve in stone. A number taken from a breathing, rippling, drifting surface is a moment, a single frame, true for the instant it was caught and subtly different the next. When the two spacecraft disagreed about the texture of the boundary, one ragged and one smooth, they were not contradicting each other. They were honestly reporting a surface that had genuinely changed between their two visits, the way two photographs of the same sea taken 6 years apart would show different waves without either being wrong, and it means the deepest features they found, the unturned field and the gathering pressure, are themselves likely to shift over time, breathing along with the boundary, so that even the mystery is not a still thing to be pinned down, but a living pattern to be followed. We did not measure a statue. We took the pulse of something immense and slow and alive, and a pulse, by its nature, is never quite the same twice. That phrase, local interstellar weather, deserves a moment, because it is a real thing, and most people have no idea it exists. The solar system is not sitting in some uniform, featureless galactic medium. Right now, our Sun and its bubble are drifting through a particular clumpy patch of warm, thin gas, a cloud of interstellar material that the local stars have stirred up, sometimes called the local interstellar cloud. We are inside this cloud now, near one of its edges, and in the grand scheme of galactic time we're only passing through. And this cloud sits inside something larger still, a structure that gives the whole arrangement a kind of history you can almost read. Our local patch of cloud, and a number of neighbouring clouds, all float within an enormous low-density cavity in the galaxy, a region where the gas is unusually thin, hundreds of times the distance to the nearest stars across. Astronomers call it the local bubble, and its origin is genuinely dramatic because it appears to have been carved out by violence. Long ago, a series of massive stars in our part of the galaxy reached the ends of their lives and exploded, one after another over millions of years, and the blast waves from those explosions swept up and pushed away the surrounding gas, hollowing out the great cavity we now drift through. The thin, mild conditions just outside our heliosphere are, in a real sense, the calm left behind by ancient catastrophes, the cleared-out aftermath of stars that died before our species existed. So the solar system is not sitting in some changeless backdrop. It is a small boat sailing through a sea with its own currents and its own weather, drifting through this particular mild cloud now, headed eventually toward its edge and beyond, into whatever lies in the next patch of the bubble. The sun moves through the galaxy at a steady pace, and the direction it is heading even has a name among astronomers, the point on the sky the solar system is sailing toward. As we move, the conditions just outside the heliosphere slowly change, and with them the size and shape of our protective wall. Tens of thousands of years ago, the boundary the Voyagers crossed sat at a somewhat different distance, and felt somewhat different conditions, and tens of thousands of years from now it will again. The wall has a past and a future. It has been bigger and smaller. The Voyagers caught it as it is right now, in this cloud, in this stretch of the long voyage, and that snapshot, precious as it is a single frame from a film that runs for millions of years. Tens of thousands of years ago, the conditions just outside the heliosphere were somewhat different, and tens of thousands of years from now they will be different again, as the solar system drifts out of this cloud and eventually into the next patch of the galaxy, with its own density and its own magnetic field and its own pressure. The shape and size of the sun's bubble depend partly on what it is ploughing through, and what it is ploughing through changes over the long, slow eons of the sun's orbit around the galaxy. The edge of the solar system has a history. It has had different sizes in different epochs. The wall the Voyagers crossed is the wall as it happens to be right now, in this cloud, in this stretch of galactic weather, and it would have looked different to a traveller 100,000 years ago, and will look different again to one 100,000 years from now. I find something deeply calming in this, oddly enough, even though it is also a little dizzying. We like to imagine the solar system as a stable, permanent thing, the planets on their rails, the sun fixed at the centre, the whole arrangement timeless, and on human timescales it is. But step back far enough, and even the boundary of our home is in motion, swelling and shrinking with the sun's breath, reshaping itself against the changing weather of the galaxy, a slow, living membrane rather than a fixed wall of stone. The Voyagers did not photograph a monument and bring back the picture. They took the pulse of a living thing, twice, at two different moments of its breathing, and the two readings differed exactly because the thing was alive and moving between them. And this is the thread that ties the breathing boundary back to the central mystery. If the wall moves, if it flexes and ripples and shifts with the sun and the galaxy, then the strange things the Voyagers found, the unturned field, the rising density, are not simple fixed facts you could measure once and file away. They are snapshots of a dynamic, shifting, pressurized region caught at two instants. The non-turning needle and the heaping density might themselves change over time, might look different at a different point in the sun's cycle, or a different patch of the cloud. We have caught a living boundary in the act of doing something we do not understand, and we have caught it only twice, and the thing will not hold still for us to study it. That is part of why the mystery is so hard to close. You cannot easily solve a puzzle whose pieces are breathing. But there is one more piece on the table, older than the crossings themselves, a faint light from the edge that has been quietly insisting for 30 years that the boundary is fuller than it should be. We turn to the glow that shouldn't be there. Part 9. The glow that shouldn't be there. Long before either Voyager reached the wall, back in the 1990s, while both spacecraft were still climbing through the outer heliosphere with many years of travel ahead of them, they were already looking outward with a different kind of eye, and they had already caught a hint of the mystery we are chasing tonight. The instrument was an ultraviolet spectrometer, a device for measuring light at wavelengths far beyond what human eyes can see, and the particular light it was tuned to is one of the most important fingerprints in all of astronomy, a specific ultraviolet glow given off by hydrogen, the simplest and most common atom in the universe. When sunlight strikes a hydrogen atom, the atom absorbs and re-emits light at a very precise ultraviolet wavelength. Astronomers call it Lyman alpha, and because hydrogen is everywhere, this faint Lyman alpha glow seeps through all of space, a dim ultraviolet haze that fills the galaxy. The hydrogen glow was not the only surprising light from the boundary either. A separate spacecraft, a small Earth-orbiting observatory designed specifically to map the edge of the heliosphere from a distance, made its own startling discovery around 2009. Rather than catching ordinary light, this observatory mapped the sky in energetic neutral atoms, particles created at the boundary when the charged plasma of the heliosheath swaps electrons with the neutral gas of the galaxy, producing fast neutral atoms that fly back inward and can be detected and used to build a picture of the wall from afar. And when the map came back, it showed something nobody had predicted. A long, narrow, intensely bright band stretching across the sky, a ribbon of unexpected brightness arcing around the boundary of the solar system, far brighter and far more sharply defined than any model had anticipated. The ribbon, as it came to be called, was an instant mystery, and the leading explanation tied it, once again, to the geometry of the interstellar magnetic field draped around the heliosphere, the same draped field that the Voyagers found refusing to turn. So even the remote maps made from near the Earth agreed with the message the distant spacecraft were sending. Every way we have found to look at the boundary, by ringing plasma, by drifting cosmic rays, by ultraviolet glow, by maps of neutral atoms, has come back with the same refrain. There is more structure out there than we expected. There is a brightness that should not be so bright, a glow that should not be so strong, a ribbon that should not be so sharp, a field that should not be so aligned. The edge of the solar system keeps showing up, in instrument after instrument, as fuller and more organized and more surprising than the simple textbook picture allowed. The Voyagers are the only ones that have actually touched it, but everything we can see from a distance agrees with what they felt up close. The Voyagers, looking outward in the 1990s, measured this hydrogen glow coming from the direction of the boundary, the region ahead of the heliosphere, and there was more of it than a simple model predicted. The glow was a little too bright, as though there were extra hydrogen out there near the edge, more atoms than the basic picture allowed, piled up somewhere ahead of the spacecraft, catching the distant sunlight and glowing faintly back. And this fit beautifully with an idea that theorists had been entertaining for years, the idea of a hydrogen wall. Here is the thought behind it. The interstellar medium is not only charged plasma, it also contains neutral atoms, ordinary uncharged hydrogen, drifting through space. Now charged plasma feels the magnetic forces at the heliopores and gets diverted and piled up by them, which is the density wall we have already met. But neutral hydrogen atoms do not feel magnetic fields. They can drift inward, toward the heliosphere, ignoring the magnetic boundary that stops the charged particles. As they approach, though, they begin to interact with the outflowing material of the heliosphere through collisions and charge exchanges, and they slow down, and they pile up in a region just outside the bubble, a thickened layer of neutral hydrogen heaped against the sun's domain. A wall of hydrogen on top of the wall of plasma, and such a wall, lit by the distant sun, would glow a little extra in Lyman alpha. The Voyager's too bright ultraviolet glow looked like it might be exactly that, the first whisper of a hydrogen wall surrounding the solar system. For years it stayed a tantalizing maybe, because the Voyager ultraviolet data, like so much about this boundary, came from a single pair of instruments looking from a single vantage, and you cannot build certainty out of one viewpoint. And then, decades later, a third spacecraft entered the story, from an unexpected direction. New Horizons, the probe that flew past distant Pluto and kept going, carries its own ultraviolet instrument, far newer than the Voyager's 1970s hardware, and from its own position in the outer solar system, it has been measuring the same hydrogen glow. The hope was that fresh eyes might finally confirm the hydrogen wall, settle the old question, turn the maybe into a yes. What New Horizons found is, in the most honest telling, beautifully unsatisfying, and it is exactly the kind of result this whole story keeps serving up. The newer spacecraft did confirm that the Voyager's measurement was real. After accounting for the differences between the old and new instruments, the two datasets agreed well, both seeing a genuine extra glow, an excess of ultraviolet light from the direction of the boundary. So the extra light is not an error. It is there. But New Horizons did not find clear evidence that a hydrogen wall is what is producing it. The excess glow might come from a hydrogen wall, or it might come from some other, more distant source of ultraviolet light filling the galaxy, a background we do not yet fully understand. The measurement confirmed the mystery without confirming the explanation. I have come to think there is something quietly admirable in a result like that, something worth pausing on. It would have been easy and satisfying to announce that the fresh instrument had found the hydrogen wall and closed the case. Instead, the careful answer was the honest one. The extra glow is real. Both old and new eyes agree on that, and we do not yet know for certain what produces it. That is science doing the harder, truer thing, refusing to claim more than the data supports, leaving a question open rather than dressing up a guess as an answer. And it fits the whole shape of tonight's story, which is, at bottom, a story about the courage to say we do not know. The people closest to this boundary, the ones who have spent their lives measuring it, are precisely the ones telling you it is unexplained. They are not hiding a secret. They are standing at the edge of what can currently be known, pointing outward and saying honestly that the answer lies farther out than anything we have managed to send. There is extra light coming from the edge of the solar system. Both old and new instruments agree, and we are not certain what is making it. Sit with how perfectly this rhymes with everything else tonight. The magnetic field does something we did not predict, and the leading explanation only relocates the strangeness. The density climbs where we expected emptiness, and we cannot tell where the pile-up ends. And the oldest clue of all, this faint ultraviolet glow, confirms that there is more out there at the boundary than the simple picture allows. An excess of light, a possible wall of hydrogen, while stubbornly refusing to tell us exactly what it is. 3 separate measurements, taken by different instruments across 30 years, the magnetism, the density, and the light, and all 3 point the same way. The edge of the solar system is fuller, thicker, more crowded, and more active than the clean wall of the textbooks. Something is heaped up out there. The plasma is piling up, the field is draped and tangled, and the light says there may be a wall of hydrogen on top of it all, catching the last of the sunlight and glowing back at us, a faint halo around the entire solar system that we can see but cannot fully explain. When the people who supplied the title for tonight chose the phrase "we are surrounded," this is part of what it means, stripped of any drama. We are quite literally surrounded, not by a void, but by a boundary that is crowded with piled-up matter and tangled field, and a faint, unexplained glow, a shell of compressed galaxy pressed against the outside of our sun's bubble. We did not find emptiness at the edge of home. We found a thickening, a gathering, a wall in 3 different kinds of evidence at once, and the deepest question, the one that turns all of this from a list of curiosities into something that touches your own life, is what that wall is actually for. Because it is not only strange, it is also, it turns out, the thing that has been protecting you and everyone you have ever known for your entire life. We turn now to what the bubble is for. Part 10. What the bubble is for. We have been treating the heliosphere as a curiosity, a strange and beautiful structure to be measured and puzzled over, and it is that. But I have been holding back the part that should change how you feel about the whole thing, the part that turns this from an abstract story about distant physics into something that has been quietly shaping every single day of your life. The bubble is not just there. The bubble is doing something. It is a shield. And the strange thick wall the Voyagers found, the one that gets heavier the farther you go, is the outer rampart of the only thing standing between us and the full force of the galaxy. Here is what the galaxy is throwing at us, all the time, from every direction. Out in interstellar space, between the stars, the cosmos is filled with what we call galactic cosmic rays, which is a slightly misleading name because they are not rays of light at all. They are particles, atomic nuclei and high-energy protons, flung out by the most violent events in the galaxy, the explosions of dying stars, the shock waves of supernovae, the churning fields of distant catastrophes, accelerated to nearly the speed of light and sent screaming across the galaxy for millions of years. They are radiation in the most dangerous sense, energetic enough to tear through matter, to break apart the molecules of living cells, to damage the delicate machinery of DNA. The galaxy is sleeting with them. Space between the stars is a far harsher and more irradiated place than anything we experience on the ground. And the reason we do not experience it, the reason you have lived your whole life without ever once feeling the brunt of that galactic radiation, is the heliosphere, the sun's bubble, inflated by the solar wind and bounded by that strange thick wall, pushes back against the incoming cosmic rays and deflects a large fraction of them away before they ever reach the inner solar system. Remember the very signature of crossing the wall, the thing both Voyagers measured, the sharp jump in cosmic rays the moment they pass to the outside. That jump is the shield becoming visible. Inside the bubble, the cosmic ray count is suppressed, held down, because the heliosphere is actively blocking them. Outside, it leaps up to the full galactic level, because out there, beyond the wall, there is no more protection. The Voyagers did not just measure the edge of the sun's domain, They measured the edge of our shelter. They stepped out from under the roof and they recorded in the rising radiation exactly how much that roof had been keeping off of us. It helps to be clear about which roof we are talking about, because the Earth actually has two shields, nested one inside the other, and people often confuse them. The inner shield is the Earth's own magnetic field, the magnetosphere, generated by the churning of our planet's molten core, and it does a fine job of deflecting the lower energy particles that stream from the sun, the ones that cause the auroras and the occasional radio disruption. But the magnetosphere is small, a local bubble around our single planet. The outer shield is the heliosphere, and it is the one that handles the harder problem, the galactic cosmic rays, the high-energy particles flung from exploding stars across the galaxy, which are far more energetic and far harder to stop than anything the sun produces. Those are the particles the heliosphere turns away across the whole span of the solar system, long before they ever reach the neighbourhood of the Earth. Two shields then, one planetary and one stellar, and the Voyagers flew out past the larger of the two and measured directly the harsher sky beyond it. And the reason this is not merely an abstraction is that the harsher sky has teeth. Galactic cosmic rays are energetic enough to pass through metal, through rock, through flesh, and when they tear through living tissue they can break the long molecules that carry the instructions of life, snapping strands, scrambling code, leaving damage that a body must scramble to repair. On the ground, under both shields and under the thick blanket of the atmosphere, we are almost entirely spared this, which is part of why life has been able to flourish here at all. But step outside the protection, as any future traveller who tried to cross the wall would have to, and the radiation becomes one of the central problems of survival, a steady invisible sleet that no amount of courage can simply push through. The Voyagers, being machines, endure it without complaint, their hardened old electronics shrugging off particles that would be a slow danger to anything alive. They are scouts in a country we ourselves are not yet built to enter, sending back word of how hard the weather is beyond the last shield, so that we might understand, long before we ever try to follow, exactly what we would be walking out into. And we have reason to believe the strength of that outer shield has mattered, concretely, in the history of our planet. Buried in the seafloor and in the layers of the moon, scientists have found traces of a particular kind of radioactive iron that does not form naturally on Earth, an isotope that is forged in supernovae and sprinkled across space when massive stars explode. Its presence in our planet's sediments is read as the fingerprint of nearby stellar explosions in the relatively recent geological past, blast close enough and strong enough to have compressed the heliosphere and showered the solar system with debris. In other words, the shield has been tested. The galaxy has thrown real violence at us before, within the span of life's history on Earth, and the heliosphere has stood between that violence and the living world. How well it stands, how much it lets through, how it responds when the sun quiets, or the local cloud thickens, these are not idle questions. They are part of the long, slow story of why this planet has remained habitable, and they depend on the physics of a wall we have measured exactly twice. Now bring back the density wall, the pile-up of matter the Voyagers found heaping up against the outside of the bubble, and let it change its meaning. When we first met that wall, it was eerie, the unexpected thickening of space where we expected emptiness, the gathering pressure pressing against everything we call home. But that same heaping, that same pile-up of compressed plasma and tangled magnetic field at the boundary, is part of how the shield works. The wall that gets heavier the farther you go is not just a strange feature of the edge, it is part of the rampart. The compressed plasma and the piled-up draped magnetic field at the heliopause form a magnetic barrier, a kind of reef, that helps turn away the incoming cosmic rays, that regulates how many of those galactic bullets manage to leak through into the bubble where we live. Voyager 2, with its careful, real-time measurements, actually detected this barrier directly, a layer of intensified magnetic field just inside the wall that strongly influences how cosmic rays get in. The heaviness is protection. The thing that was eerie is the thing that has been keeping you safe. That is the shift I wanted you to feel. The wall that gets heavier the farther you go is the wall that has been shielding every life that has ever lived. And this is where the mystery stops being academic and starts being something with real weight for the long future of life on this planet. Because if the boundary is thicker, stranger, more magnetized, and more changeable than every model assumed, then the strength of our shield is governed by physics we have only just begun to measure, with a sample size of 2. The amount of cosmic radiation that reaches the inner solar system is not fixed. It depends on the state of the heliosphere, on how hard the sun is breathing, on how inflated the bubble is, on the local interstellar weather the solar system happens to be sailing through. We know that the sun's 11-year cycle changes the cosmic ray flux even now, in small ways we can measure at Earth. We know the bubble breathes, and we know, from the long history of the galaxy, that the solar system has drifted through denser and thinner clouds in its past and will drift through more in its future. Clouds that could compress the heliosphere, shrink the shield, change how much radiation gets through over spans of tens of thousands of years. This is not a doomsday claim, and I want to be careful not to dress it up as one, because the truth is interesting enough without alarm. We're not in any immediate danger from the galaxy. The shield is strong, and the sun is steady, and the cloud we're passing through is mild. But over the long, slow timescales of planetary and biological history, the strength of that shield is one of the quiet background variables that help set the conditions for life. The radiation budget at the Earth's surface over millions of years, the rate at which cosmic rays seed certain processes in the atmosphere, the protection available to any future travellers who might one day try to cross the boundary themselves, all of it depends on the physics of this wall that we have measured exactly twice. The heliosphere is one of the unsung reasons the Earth has been a place where complex life could develop and persist, a sheltering bubble we did not know we lived inside until 2 old spacecraft flew out of it and told us how much colder and harsher it is on the other side of the wall. There is something I find quietly moving in the fact that we only learned the shield existed by leaving it. For all of human history, the heliosphere was doing its work invisibly, silently, deflecting the galaxy's radiation away from the cradle of life without anyone knowing it was there. We could not see it. We could not feel it. We had no way to even know we were being protected. And then we built 2 machines, eyes from before the home computer, and we flung them outward for 40 years, and only when they crossed the wall and the radiation jumped did we finally understand what had been sheltering us the entire time. We had to step outside the house to learn that there had been a roof. That, to me, is the real meaning hidden inside the strangeness, the gift buried in the mystery. The wall the Voyagers cannot fully explain is the wall that made us possible, and those 2 spacecraft that revealed it are themselves now reaching the end of their long lives, which is the part of the story I've been gentle about and which we have to face now, near the end, together. Part 11. 2 failing voices and no one coming. I have called them old machines several times tonight, and I have said lightly that they are dying, and now I want to tell you what that actually means, because it is the part of this story that I think about most when the rest has faded, and because it gives everything we have discussed a tenderness that the physics alone cannot carry. The Voyagers run on heat, not on sunlight, because sunlight is far too feeble out where they are, 1,000 times fainter than it is at Earth, and growing weaker every year. They run instead on the warmth of a slowly decaying lump of radioactive material on board, a small steady source of heat that has been quietly turning into electricity for nearly 50 years. And the trouble with such a source is the trouble with all such things. It fades. Every year the material decays a little further, the heat dims a little more, and the power available to the spacecraft drops by about 4 watts. 4 watts a year. The electricity that runs the most distant human-made objects in existence is draining away at the rate of a small flashlight bulb, annually, with no way to ever refill it. For decades the engineers have managed this fading budget with a kind of devotion that I find genuinely beautiful. As the power has dropped, they have made hard choices one after another about what to keep alive. They have turned off heaters, letting parts of the spacecraft grow colder than the engineers who built them ever intended, hoping the ancient electronics would keep working in the deepening chill, and astonishingly often they have. They have switched off instruments one by one, the cameras long ago, then others, each shut down a small irreversible amputation, a sense permanently lost to stretch the remaining watts a little further. The people who do this work speak about the spacecraft the way you might speak about a very old relative whose world is slowly narrowing, deciding with great care which capabilities are worth the dwindling energy, trying to keep the most precious senses alive the longest. And the most precious sense, the one they are fighting hardest to preserve, is exactly the one that matters for tonight. The ability to keep measuring the space around them and sending those measurements home. The listening itself is its own quiet feat of devotion. The signals from the Voyagers are caught by a network of enormous radio dishes spread around the Earth, antennas tens of yards across, built precisely to hear the faintest whispers from the most distant spacecraft. By the time a Voyager signal arrives, after crossing more than 15 billion miles, it is almost unimaginably weak, a power so small that catching it at all is like trying to hear a single voice murmuring from the far side of a continent. The dishes strain to pull that murmur out of the constant noise of the universe, and they succeed, again and again, day after day, decade after decade. And the conversation gets slower every year as the spacecraft recede. A command sent from Earth now takes most of a day just to arrive, and the answer takes most of a day to come back, so that the simplest exchange with one of these machines is a patient 2-day affair, a question whispered into the dark on one day, and an answer returning on the next. The people who keep this going speak about the spacecraft with unmistakable affection, and you can understand why. They have spent their careers tending two fragile, fading machines at the farthest edge of everything, coaxing a few more measurements, a few more years, a little more science out of hardware that by every reasonable expectation should have died long ago. They turn off a heater and hold their breath to see if the cold-soaked electronics will keep working, and somehow they do. They power down an instrument and grieve it a little and keep the others alive. It is care work in the truest sense performed across billions of miles for the sake of a thin stream of numbers that no one else could ever gather. And every one of those numbers is a small gift sent home from a place we will not reach again for a very long time, by two old friends who are running out of warmth. For as long as it possibly can, each spacecraft is trying to keep telling us what the edge of the solar system is like. Let me put you out there with one of them, in the cold and the dark for just a moment. Picture Voyager 1, more than 15 billion miles from the Sun, in a place where the Sun is only the brightest of the stars and gives no warmth at all. The spacecraft is colder than it has ever been, running on less power than it has ever had, most of its instruments long since silenced, but its wide dish is still turned back toward home, toward a pale point of light it cannot see and could not resolve if it tried, and at intervals it still gathers what its few surviving senses can detect: the faint density of the plasma around it, the direction of the magnetic field, and it gathers its strength and it sends. The signal it sends is unimaginably weak by the time it has crossed 15 billion miles, so faint that catching it at all requires some of the largest radio dishes ever built, straining to hear a whisper against the noise of the universe. And that whisper takes the better part of a full day to arrive, crossing the gulf at the speed of a light and still needing most of a day to do it. A message sent into the dark tonight, arriving home tomorrow from a machine older than almost everyone who will ever hear about it, still doing its job, still reporting from the frontier, still faithfully describing a wall it does not understand to a species that does not understand it either. And here is the hard part, the part there is no comforting way around. When they are gone, no one is coming. There is no successor. There is no second generation of interstellar probes built and waiting on the launch pad, no funded mission designed to follow the Voyagers across the wall and keep going where they left off. The ideas exist. Scientists have drawn up careful designs for a true interstellar probe, a spacecraft built from the start to cross the heliopause and travel far beyond it, to find the things the Voyagers could not reach, the place where the field finally turns, the far side of the density wall, the true undisturbed galaxy. But ideas are not spacecraft. Nothing has been funded, nothing is being built, and even if such a mission were approved tomorrow, it would take many years to construct and launch, and then decades more to fly out to the boundary the Voyagers crossed long ago. The most optimistic timeline still means a gap, a long silence, between the moment the last Voyager goes quiet and the moment any new voice reaches the wall. A gap measured not in years but in decades, possibly in a substantial fraction of a human lifetime. Let that arithmetic land for a moment, because it is sobering in a plain, undramatic way. Suppose, hopefully, that a successor mission were approved in the next few years. It would take many years to design and build a spacecraft meant to outrun the Voyagers, and then, once launched, many more years simply to climb out to the wall, a journey that even with faster technology would consume decades. Added up, and a child born today could easily be middle-aged before any new human-made object crosses the heliopause again. And that is the optimistic case, the one where we decide soon to try. In the case we're actually living in, where nothing is funded and nothing is being built, the gap only grows. So the measurements the Voyagers are sending right now are not merely our best current data. They may well be the only first-hand data any living person will ever have about the edge of the solar system. The window is open tonight. It will not stay open, and there is no guarantee anyone will be at the wall to reopen it within the lifetimes of anyone listening, which means that the two readings we have been discussing all night, the needle that would not move and the wall that gets heavier the farther you go, are not just our best current data about the edge of the solar system. They are, for the foreseeable future, our only data, and they are about to stop updating. When the last instrument on the last Voyager finally falls silent, the most important first-hand map humanity possesses of its own place in the galaxy will simply freeze. It will not be wrong. It will just be finished, complete, closed, a 2-point data set that has to stand, perhaps for generations, as the entire sum of what our species has directly learned about what surrounds our star. Every textbook, every model, every theory of the heliosphere for decades to come will be built on the measurements these two fading machines have already sent or will manage to send before they go. We are watching the source of our knowledge about the edge of home approach its own end with nothing prepared to take its place. I think that is why the people who work with these spacecraft speak about them with such evident love, and why I cannot tell this story coldly either. It is not only that the Voyagers are far away and old and remarkable, though they are all of those things, it is that they are irreplaceable in a very literal sense, the only witnesses we have or will have to a place we cannot otherwise reach, and they are dying, and we have not built their heirs. There is a window open right now, a thin and closing window, during which two human-made objects are still out there past the wall, still listening, still reporting, still able to surprise us. When that window closes, it will not reopen for a very long time. So the strangeness they found, the unexplained field and the heaping density, is not a puzzle we can simply assign to the next mission to solve. There is no next mission. There is only what these two can still tell us, in the time they have left, before the most distant voices our species has ever raised finally fall quiet in the dark. And that brings us, at the end of the night, back to the wall itself, and to what it really means that the edge of the solar system is not an edge at all. Part 12. The membrane, not the end. So let us gather what the two old voices have told us, and stand at the wall one last time before we let the night carry us off. We set out with a simple, comfortable picture of the edge of the solar system, a clean line, a door, a finish line, the place where the sun ends and the galaxy begins. We send two machines to cross it, and they do cross it. By every honest measure, they leave the sun's bubble, the wind dies, the cosmic rays surge, the plasma sings its high interstellar note. And then, at the threshold, both of them quietly take the clean picture apart in our hands. The needle that didn't move, that was the first thing, and it is still the strangest. The magnetic field was supposed to swing as the spacecraft left the sun's domain, the cleanest signature of all, and at both crossings, 6 years and a hemisphere apart, it refused. The galaxy's field, at the only two places we have ever touched it, lies combed into near alignment with our own stars, as though the sun's reach does not stop at the wall, but presses through it, draping itself across the boundary, gripping the field beyond, writing its signature into the galaxy farther than its own light has ever clearly let go. We never found the place where the needle finally turns. As far out as either spacecraft has gone, the sun is still there in the field around it. We sent 2 probes to leave home, and they could not find the edge of home's reach. And maybe that is the gentlest way to hold all of it, as the night closes in. We went looking for the place where home ends, and we did not find it. We found instead that home reaches farther than we knew, that the sun's hand rests on the galaxy past the wall we drew for it, that the edge is not a door slamming shut behind us, but a soft and braided border we have only begun to feel our way across. There are lonelier ways the universe could be arranged. It could have given us a hard line, a cold finish, a clean nothing on the far side. Instead, it gave us a membrane that still carries the warmth of the star that made us, a boundary that shields more than it separates, a wall that turns out, when you press on it, to be holding the galaxy gently off of the only world we have. We did not find the edge of home. We found that home, in some quiet and stubborn way, comes farther with us than we ever guessed, the wall that gets heavier the farther you go. That was the second thing, and it rhymes with the first. We expected the edge to be the beginning of emptiness, and instead, the deeper the spacecraft pushed, the thicker space became, plasma heaping up, density climbing, a front of pressure pressed against the outside of the bubble. And then we learned what that heaviness is for, that it is part of the shield, part of the rampart that has turned the galaxy's radiation away from the cradle of life, for longer than there have been minds to wonder about it. The wall that was eerie became the wall that protects us. The strangeness became the roof over our heads, and both findings, the field and the density, say the same thing in two different languages. The boundary of the solar system is not a line. It is a thick, breathing, pressurized membrane, a braided borderland where the sun and the galaxy are tangled together across a span we have not been able to measure the far side of, a living skin rather than a wall of stone. We are surrounded. That was the phrase we started circling, and now you can hear everything in it. We are surrounded not by a void, but by a boundary crowded with piled-up matter and draped field, and a faint, unexplained ultraviolet glow, a shell of compressed galaxy heaped against our sun's domain, a wall that shows up in three separate kinds of evidence and refuses to fully explain itself in any of them. We are surrounded by a shield we did not know we had until we flew out of it. We are surrounded by the reach of our own star extending past the edge we drew for it. We are surrounded by a mystery measured by two fading machines, and for now, by no others. And those machines were eyes built before the home computer. I keep returning to that, and now you know why it stopped being a charming little fact somewhere along the way. These measurements, the most profound boundary measurements in the history of our species, the only first-hand knowledge we possess of what surrounds our star, were gathered by instruments designed in the early 1970s, with less memory than a single photograph on your phone, running now on the fading warmth of a decaying ember, sending their findings home in a whisper that takes most of a day to arrive. The grandest map of our place in the galaxy was drawn by the humblest of eyes, and those eyes are closing, and we have not built their replacements. There is something almost unbearably human in that, in the gap between the smallness of the instruments and the size of what they found, in the tenderness of two old voices still faithfully reporting from a frontier neither they nor we understand. So what is the one thing both Voyager probes recorded that nobody can fully explain? On the surface, it is the field that would not turn, the magnetic needle that held still where every theory said it should swing. But underneath that single measurement is the larger thing it revealed, the thing that the density and the glow and the breathing boundary all confirm in their own ways. The edge of the solar system is not an ending. It is a membrane that still carries the imprint of the star inside it. We crossed it exactly twice, with eyes built before the home computer, and we found not the clean line we expected, but a thick and living frontier still wearing the sun's fingerprint, still heaping the galaxy against our door, still shielding us, still keeping its secrets. We do not know how far it really extends. We do not know what it would feel like to finally break free of it, to reach the place where the sun at last lets go and the true galaxy begins, because nothing we have built has ever gotten there, and nothing we have built ever will until we choose to try again. For tonight, that is enough. Two voices, 50 years out, still whispering home across the dark, telling us that the wall at the edge of everything is stranger and fuller and more alive than we ever imagined, and that even there, even at the farthest reach of all our long endeavour, we are not as far from home as we thought. The sun is still with them. It is still with us. And somewhere out beyond the place where the needle would not move, in a thickening dark that two old machines have only begun to measure, the real edge is still waiting, patient, unhurried, for whoever we become next. Rest easy. The wall is holding. And the two faithful voices are still out there, in the cold and the quiet, keeping watch a little longer.